Yeah, from California, but British, so no escape from the British accents. I'll get out of the way as well. So this is going to be a very techie presentation compared to a lot of the other ones, because I'm an engineer. So this is about Electric Imp, and I just kind of introduce myself first, like sort of what my background is, what I've been doing, kind of since I grew up. I've worked on a lot of stuff over the last, I recognize an intern, hello. Over the last 20 plus years. I kind of started off when I was a teenager. I made communication software, bulletin boards. Anyone remember those? Remember bulletin boards? I wrote bulletin board software. I did QZAR laser tag. If you've played laser tag, you've probably played with my gun code. Q2000 is one with 2 triggers. Yeah, invisible bullets and stuff like that. It's good. 300. These are just like, what I've put here is like what I did, kind of roughly, and kind of my summary in one sentence, what it was. That was 304 bytes of RAM, very, very small in those guns. They're kind of cheap stuff. I did a startup called MPEG. We made in-car MP3 players. That was an early hardware startup in the late 90s, before there were cheap places to get PCBs. So we learned a lot of very hard lessons there. But it was a lot of fun, and it was all about music, and we had a great time. We got acquired by a company that went Chapter 11 within the share lockup period, so we made nothing from it. But we had a great time, so that was cool. That's a recurring theme actually coming through here, which was Rio. Anyone ever had Rio MP3 players? Remember those? The ones that Apple wiped out? If you can't beat them, you join them. That's how it works. So we did MP3 players, and that was one of the things where we made great products. They were really good, especially the later ones. But it turned out that actually marketing is really important, and Apple comes in with marketing, with actually technically inferior products, and wipe us out completely. So that was kind of interesting, making MP3 players. But again, this was like, we made 4,000 MPEGs, and these were $2,000 car MP3 players. Luckily, at the very peak of the market, when every geek was at a .com startup and had money, so we sold all the ones we could make. But then the market went like that, and we couldn't sell so many. Rio, they made some really good products, really great MP3 players, but unfortunately Apple outmarketed them and they lost it completely. So I went to Apple in 2006. I managed the iPhone hardware team for 4 years, and I was iPhone architect for a year. That was actually really, really fun. Apple is a really tough place to work in some ways, but the stuff you learn there is incredible. People think Apple's a marketing company. You go there as an engineer. Oh, no. It's the most amazing engineering company in the world. And actually, unlike most other companies, they have the money to do engineering. They actually spend money on this stuff. They research stuff. They go into every bit of detail. If you're going to make 100 million of something, you've got to know what you're doing. It's an amazing operational machine and an amazing place to be. And there I met Tony and Matt and people like that. And I did the hardware architecture for the first Nest, so the first thermostat on the wall. I have some very embarrassing pictures from the first Nest office. And if anyone has some problems with power stealing, it's because it was modeled after my boiler. It works perfectly with mine. I have serial number 1 on the wall, by the way. Unfortunately, in hindsight, I didn't join Nest, otherwise I'd be on a beach at this moment. But again, it's really interesting. So I've always been into communications. And and Apple was great making cell phones. I used to be a cell phone junkie. I used to buy about 5 or 6 cell phones a year and then sell them on eBay because I got bored with them. They'd never live up to my expectations. And then I went to Apple, and that cured me of that because I just always had the latest phone. It was great. But so I went to Nest. For me, I was looking at it, and it's very Apple-ish. I say iPod too. It's actually built in the model of really iPod, the way it works. Most of the people are from iPod. But they were solving one problem. They were, the one problem at a time, very Apple-y, very ground up. We're going to make every piece, the housing, all the software, all the servers, everything, do this building thing, and make a product. And they make a great product, just like Apple make great products. However, it wasn't like going to, as an engineer, I've been waiting for flying cars for decades, and nothing was happening. All this stuff hadn't happened. Connected devices weren't happening. It was like, guys, why aren't things happening? I've bought a $200 set of bathroom scales that when I step on it sends 4 bytes to my phone. And you work it out per byte how much I'm paying for this. It's actually quite a lot. I think you use it once a day. And so it was like, well, that's the problem. There's all these point solutions. People are just making stuff, and it's so hard to make a connected device that really people spend months and months or years building something that just works to be connected, and then they go, oh yeah, what was the product I was making? Oh yeah, and it tends to end up being a little lackluster and a little not a great product. And what Nest did and what Apple do is think a lot about what is the product? How am I going to interact with it? How's it going to work? And if you're having to do that and the mechanics of the back end, something has to give usually. Especially in smaller companies, something gives, you run out of money or whatever, and that's why a platform is a great thing to have for a connected device. And that's what Electric Imp is. Electric Imp is a platform to build connected devices on. Quirky use it in some things. These screens here are showing products which all have imps in them. So I started Electric Imp. And this is really, connected devices are hard to build. I don't know anyone here anyone put your hands up if you're trying to build a connected device? Trying really hard, 2 hands. It's hard. There's a lot of moving parts in there. You want to get it secure. You want it to be easy to set up. It has to work as the product you're trying to build. And there's all these different choices of connectivity and da-da-da-da-da. So we kind of went, okay, let's just be Apple-ish about this. Let's be really, really pig-headed and just go, hey, it's just going to use Wi-Fi. Sorry, no Zigbee, no Z-Wave, no BTLE, whatever. Just picking one thing and actually going for it and saying, this is going to satisfy most people in most markets. And we think it's going to work really well. So we picked Wi-Fi. We invented our own protocols just to make it work, because there's a lot of standards out there, and that's the problem. There are a lot of standards out there, and they're all standard, but none of them talk to each other. So we kind of went, okay, the standards are HTTP, because web guys can talk to that. It works. We sorted out things like security. We sorted out how to, when you ship thousands of products, how do you update the firmware on them seamlessly without the user noticing? How do you just make it better? We dealt with that. And we dealt with getting connected as well. The whole out-of-box experience is always a pain with connected devices. So yeah, platforms really help. We do all these things. Wonderful. If you want more information, come and ask me afterwards. But I'll go quite quickly, because I know people usually have some questions, maybe. So kind of what we have is we have an OS and we have a virtual machine in the hardware. So actually, when you build a connected product with IMP, this thing here, here's this SD card version is kind of the one which you can buy from Adafruit and SparkFun and places like that. But there's one that solders onto your board as well. But really, what it is it's an embedded microcontroller with communications. So it's not just a Wi-Fi module. It's not just a software stack, it's everything together. This thing you put down, and to give an example of how weird this is for embedded development and how new this is, at CES, not this year, the year before, I drove there, and I dropped one of these running from 2 AA's into a bush 150 miles outside Las Vegas, because I found some open Wi-Fi at a mall. And I dropped it in a bush about 100 meters away from the mall, and it's online. I could go into our web-based IDE, edit, update code, all this thing which is in a bush. And I could tell the temperature and humidity of the bush. I wasn't that interested. It did get near freezing, but no frost. It was good. I actually wrote my name, and I was like, this is not a bomb, because it was wrapped in black duct tape. I didn't know if it's going to rain in the desert. Turns out it doesn't. But there's condensation. But this is, when you're developing something, generally, when you build something, you put it on your desk, and you have a wire hooked up to your computer, and you hack away, and then at some point you get brave and you unplug the wire and see if it works on its own. With this, it's kind of really weird, because instead what you do is you can be anywhere. You don't your customers can have these, and you can debug problems your customers have live when they're on the phone, even if they're in Australia. It's just like, yeah, cool, I'll just see that. Oh, that's what's happening. I'll just fix that for you, which is great during development. Really, really speeds your time to market. The other nice thing about it, though, is that once you've got this, you want to make 1 million things? That's cool. You can just buy 1 million of these. It scales horizontally. This is not like an Arduino. Arduinos are great, don't get me wrong. But if you make something with an Arduino, then you want to make 100,000 of them. Really, you're redesigning your entire product at that point. You're not taking the Arduino and buying 100,000 of them, because it's not really designed to scale. It's designed to be very easy to prototype with, has big connectors, is robust at different power levels and stuff. Whereas these, you kind of get the commercial thing, but we let you buy one of them, and we let you have all the tools and do stuff without actually having to commit to signing NDAs or doing anything like that. All our documentation is online. You can just buy it from all these places and build stuff. And it has this wonderful configuration thing called Blink Up, which you point your phone screen at it and it blinks and sends your Wi-Fi details across and nonces and does security stuff. But anyway, that's that end. But that's not all. Sounding like a salesperson. Kind of when you have embedded devices, one of the problems is that, if you want to make, say, a sprinkler system which doesn't water your plants when it's raining, you kind of go, okay, I need to speak to a weather service. Oh, I'll speak to Yahoo. And generally what that means is you end up, putting code down on this tiny thing running on maybe on batteries to parse all these responses from, a huge web server somewhere. And it's like, this isn't fair. The web server's ganging up on this. It might send half a meg web page or something down to it, and it has to just throw most of it away and get the 1 byte it needs. So what we do is we have another one. So we have a VM here in your thing, and there's a VM in the cloud. And every one of these gets one of these. So if you have 100,000 devices, you have 100,000 VMs. So you can just write one slice, and then we scale it. So one of the comparisons we kind of say this is like this whole infrastructure thing is kind of like AWS for things. So AWS, no one goes, hey, I'm going to want to start a website. Let me just go and buy some servers. No one says that anymore, which is a shame because buying servers is fun. Maybe that's just me. I've got pictures of myself stroking the CPUs on one of my last startups. It was the most powerful machine we'd ever bought. But anyway, no one buys servers. You just go to AWS and go click. It's very boring. You don't get to see them. But they're there and they work. And the point is it allows you to scale. You want 10 servers? Click, 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 click. Well, you probably there's an API to do it, but yeah, same sort of thing. But really, this scalability is really important, and it allows you to do up in the cloud. This one here is it's small and has 128K of memory and is cheap and will run off 4 microamps and stuff like that. This one here has a meg of RAM and runs on an Amazon server farm, so you don't have to worry about it's not going to run your battery down. And the one in the cloud does all the talking to the cloudy type things. So you can be doing JSON parsing and HMAC hashing and all the stuff that web people get excited about. And then you can program it all online. You just need a web browser. Finally gives you something to do with that Chromebook you have. And there's a I know everyone has a Chromebook because they're $200. I mean, really? I did work for Chrome OS for 2 weeks, by the way. There's a chip in my 2 weeks. I designed a chip into the Samsung Chromebook. That was my entire contribution. I was only there 2 weeks because the day after I arrived, they announced Android at home, and I went, oh, that kind of clashes with my idea. Probably better leave. And there's there's all these admin tools to deal with lots of stuff, and you can talk to anything. You can talk to Twilio and send text messages, and you can fetch random movie quotes and make one of those little clapping monkey things, speak taxi driver quotes in the middle of the night at a hackathon, and it's really quite disturbing. Yeah, it is, because, it just is. We do hackathons and we make very, very stupid things. I have a cowbell. I made it one of the last ones. It's just a cowbell and a solenoid. And it was hooked up. If anyone said the word cowbell on Twitter, it was a live real-time Twitter. The agent here is hooked up to Twitter's live API. And if anyone says cowbell, the cowbell goes off. It turns out people say cowbell a lot in aggregate. So we turned that off, and now I just annoy people in the office when I'm remote. I just go click my cowbell link, and it rings, and they're like, oh. Anyway. So I've done stuff. So that's kind of. I'll just go back, and I'll give you the tips in a moment. So electric imp is that. If you want to make a connected device, it's worth checking it out. It's like $25 for one if you want to buy one. And we have a great community. There's forums. We welcome suggestions. We have great interns. Have had great interns. If you want to intern with us for anything, then email us as well. We're based in Los Altos in California. So, going to give you the lessons about hardware. And these are things I've picked up over time. Always design for functionality, not for cost, at the beginning. Too many people are like, oh, well, I can't do that because that's expensive. And it's like, if you're going to make 100 at the beginning or 1,000, and if you sell all 1,000, then you can think about maybe making it a bit cheaper. But if you try and squeeze all the cost out at the beginning, you're like, I'm going to go for the smaller CPU, which doesn't have as much flash, doesn't have as much RAM, it might mean you can't ship because you can't optimize your code in time. You'll spend 3 months more optimizing your code and you've missed your opportunity. So it's always worth over-specifying. I took this to extremes on the car MP3 player. It had a 220 megahertz strong arm, which was the fastest one you could buy. But it meant actually we didn't have to optimize our software as much, and we could ship 3 months earlier, and that was worth having. And the difference in cost was nothing compared to the software people's time. So that's really, really important. Buy the biggest app mega you're going to use. Do whatever. It makes no difference. If people like your product and use it, you can sort out the cost later. But it allows you to iterate. Without that, you can't iterate. And iteration is something which people do a lot in software. Is very hard to do in hardware if you've just tied both hands behind your back. And it's like, I haven't got any more RAM. I can't add this feature. It would be great if I could. Misuse mass market components. I've done this in various products. When you're looking to have unique features, some of the problems are, you're not Apple. You can't design your own chips. You have to buy what you can from DigiKey. The MPEG car MP3 player had no audio interface, so I misused its I2S interface with some external logic to make I2S, which worked really well, and we got great stereo audio. On the Nest, the rotary control thing, we were looking at rotary encoders and quadratary encoders. And then it occurred to me that optical mice have got this thing in it with a lens and a camera, and it's like $1. And it will sit on an I2C bus and tell you how fast something's moved. So the Nest actually has a mouse sensor in it, which looks at the housing going past to tell you whether it's moved. It turns out it's like 1/10 of the power of anything you could build yourself and cheaper. So, just think laterally. Just, when DigiKey will give you that big catalog, just browse it, put it by the toilet, and just sit there reading the DigiKey catalog, because you'll find stuff and it'll surprise you. One of the things from Apple, root cause every single failure. When you build 100 of something and 2 of them go wrong, don't just go, it's only 2. Because what happens is then when you make 200,000, there are 2,000 of them. And when you make 200 million, there are, it all scales up. Failures scale. Unfortunately, but they do. So when you have failures, take it seriously, really do. Work out what it is. Maybe it was just built wrong. Maybe there's a pin not soldered, maybe whatever. But you do want to look at that, because you don't want to be fighting that when you try and ramp. And that is something which a lot of people, and I was guilty of that on MPEG. It was just like, we had these 8 boards, we couldn't really work out what was wrong with them. And it's just like, whatever, it's not worth the time now. We didn't actually get to ramp up to huge volume, but if we had, would have been a problem. On software, now I know this is kind of like, this is what always happens. You're like, I can't do anything until the board turns up. It's going to turn up next week, and then I can solder it together, and then I can start on the software. And it's like, no, you can start on the software on anything. I always say this, and it's impossible not to fixate on this box you want on your desk. And how it works, there's a story about, on this MP3 player, I made a very bad choice of the first song it played. Well, it's a good song. It was Beastie Boys' Body Moving, Fatboy Slim remix. The problem with the Fatboy Slim remix is it sounds like it's going through audio buffer underruns for the first 10 seconds of the track. He goes, and I was actually having audio buffer underruns for about the first 2 weeks of debugging it. Then it turned out actually it was the actual song sounded like that, and I'd fixed them at some point in the past, and I just spent ages going, it's still clicking. Anyway. But really, people wait that. You can develop software on anything. You can develop Atmel software on a Linux machine. You can develop it on a Windows box, whatever. You can actually develop it. It will help. It's easier to debug on a PC. You don't have to download it with JTAG. It doesn't take as long to do compile run cycles. Software is software. It'll run anywhere. You can make an artificially restrictive environment if you want to do it. And then the other thing is optimize your edit, build, run, debug cycle time. That was the other thing, along with the don't wait for hardware. I used to send a megabyte over serial every time to try a new image, and that takes a while. It's taking sort of 5 minutes to download, and it was like, if I just spent, over the time I probably spent a month waiting for stuff to download. If I'd spent 3 or 4 days writing a USB bootloader, would have been fine. And so that's some things to think about on if you're building electronic hardware startup stuff. I've got loads of other things that I can tell you if you ask me questions or ask me afterwards. But that's pretty much it.
Thank you very much. We have time for maybe 1 or 2. If not, I'll just. Oh, sorry, over there. Yep.
Marco Periente Cohen, Mindweaver Labs. My first question, just one question. The process that you use in order to define your own protocol. You said you actually wrote your own protocol. How do you even go about doing that? If I don't know where to start.
Oh, in terms of connecting device to server?
Yes.
So because it's private to private, it's not really completely our own protocol. You look at the base, it's TLS over TCP, so it's like an HTTPS connection, and we send BSON both ways. The criteria was it has to be secure, it has to be reliable, so TCP and TLS, and we have to be able to transfer data both ways. But what we didn't do is go like, oh, we can use MQTT. Oh, MQTT doesn't really deal with firmware updates or connection maintenance or tunneling through NAT. So we didn't try and take something and hammer lots of other bits onto it. We just went, let's take something which we know will work. And the KISS principle, keep it simple and stupid. Really just keep it simple and stupid. Once it works, you can do all sorts of other stuff later. But later.
I've done some prototyping stuff with, sure. I know you like to keep it on record. I've done some prototyping stuff with the electric amp, and the thing that always kind of bugged me about it was how high level everything is. I mean, you're sending stuff over the internet, like, everything is abstracted. How did you guys decide where to set that balance between the power and efficiency that comes with working close to the metal and kind of like sacrificing some processing power to improve the developer experience?
So, really, the thing was, it had to be robust against people loading bad code by mistake. If I've nailed something to my ceiling and I've had to get the ladder out to do it, and then I crash the code on it, it's a pain to get it down. So, Cortex M3s don't have virtualization environments. It would be a pain to do some of this stuff otherwise. Really, what it turned out to be was actually processors are way fast these days. You can run a VM environment and you're kind of fine. It's maybe running a bit faster than 8-bit micro. Some bits are way faster, some bits are about the same speed. But really there's more than enough computing power going around. But the problem is using it correctly is hard. It's always hard, for example, to get a chip to go into low power mode, to gate the clocks and gate the bus clocks and turn the bus dividers up and down and stuff like that, depending on the peripherals you're using. So we decided, hey, we're going to do those, because those are the big hitters. We'll do those in our OS. And then people just use the peripherals. It also gives layer insulation, because later this year we'll have single chip solutions, which are Wi-Fi and processor in one. And you won't have to rewrite your code. It'll just work. And it'll cost less and takes less power and is cheaper. Hardware moves on so fast that actually working at abstracted level on software actually makes sense for most things. If you're going to make 100 million of something, it's worth doing it bare to the metal, whatever. If you're going to make 1 million of something, it's like kind of almost half and half, because programmers are expensive and hard to find. And also it allows us to do all these cool things like security as a service. It's our problem to keep the platform secure. If we have problems with security, we can update the software and devices without the vendor having to be involved. Which is good because people read about the fridge sending spam. It's because the fridge vendor's going like, what's the security update? Will it help sell more fridges? Turns out security updates don't sell fridges. But if there's someone whose business it is to keep that fridge secure, it's clear we keep the fridge secure. They deal with fridgy stuff, keeping stuff cold. Yeah.
All right, thank you very much. That's all the time we have. Thank you.